Welcome back. Now what's left to do for today is to look into pandas. And pandas is basically the library in Python that gives you Excel-like functionality, working with tables, reading tables, writing tables, processing data, doing things like sorting data, filtering data, aggregating data, and ultimately also visualizing in combination with matplotlib or some other visualization library. And I brought an example here that is totally not related to energy, but I think it's from some football team, Boston Celtics. But I think it illustrates the elements of the pandas data structures quite well. So the core data structure in pandas is the so-called data frame. It's just a word for table. And in comparison to NumPy arrays, where we don't have any labels on what the different indices mean, in pandas we do. We do have information about the so-called index, so that represents axis 0, the rows, as well as the columns that represent the indices of the columns, axis 1. So you could say, well, NumPy is going to be pretty useless if I have to keep track of at what position my data is stored. That index number 2 stands for Germany, and number 3 stands for France, and number 4 for China. Here we can make it explicit, and a bit like in a dictionary, we can label the rows and additionally also the columns. So take this example here. We have here an index label. It is in this case numeric. It's just like 0, 1, 2, 3, 4, 5, but it could also just be an ID, like a barcode or something. It doesn't have to be a number like in NumPy, but it can be anything. It can be a string and so on and so forth, some unique identifier that, I don't know, the text number of the person or something like that, something that is uniquely identifiable. And also the columns, these are like attributes of the players. We can give them names, like name, what team they belong to, what number they have on their jerseys, how old they are, how tall and how heavy they are, what salary they have. So each row would represent kind of an instance, a player, and then the player has different attributes, and this obviously is something that we can put in tabular format. I think that's maybe not such a big news, but it's just to illustrate kind of this is what pandas is about, dealing with this type of data. The data can have different data types. So obviously the name would be some kind of string. The age could be kind of a floating point number or an integer number, as well as the salary. And then there's some cases where there's this NaN. So NaN stands for not a number, and it just indicates kind of missing values. Maybe there's a new player for which we didn't measure its height and weight yet. So that's also something that pandas offers functionality, how to deal with missing data. And it's not just a curiosity that it's that I mentioned that, but in many data sets that you will work with, there's going to be missing data. I would say any real world data set I've seen had some form of missing data somewhere. So it works the same as with NumPy, that we need to import the package under an alias. Pandas as PD is the kind of alias of choice, but in principle, you could also just write anything and use that. Don't recommend that. Use PD, it's easy, it's short and sweet. So there's actually two main data structures, and I already introduced you to the data frame, which is kind of, you have indices and columns. but another data structure that you maybe that's maybe closer to something that you already know. Think of the dictionary, for example. You had key value pairs. The series also offers that. The series is basically one column of the data frame. It represents some one-dimensional data. For example, it could be kind of a series of the names, and the names that are then associated with the index. And just like with a dictionary where you have key value pairs, in a series you have an index that corresponds to values at the respective locations. There are different ways. So in that sense, it's quite similar to Python, where each value is associated with a key. And there are different ways, many different ways actually, to create a series. But kind of the core constructor, so the core method to build a pandas series could look like this. For example, taking a dictionary, so some data structure that is similar, where we have, this is kind of data from the kind of three last, kind of the nuclear power plants that kind of the last three that were still operating until 2 years ago, with their respective capacities in megawatts. Just as an example, you could say PD series and then pass as argument the dictionary itself. And what you would get out of that is something that just looks very similar to the dictionary itself. Just remember how that looked like. So here you had just the display of curly brackets with a colon and so on. And here you have something that looks more like a table, but you still have kind of index value pairs. Yeah. And you actually also have a data type given for this column. So that column is something that consists of integers. If I had put a 0.0 here, for example, you would see this is data type float, and actually everything else is typecasted. So that goes back to the point I was making about NumPy earlier, that NumPy arrays have a unique data type, and that cannot be mixed. And why do I mention it now? Why didn't I mention it before? Well, pandas uses NumPy as a backend for storing data and kind of only wraps around that by storing the index and the column names. So maybe let's go back, because it's always dangerous to change code on the spot while explaining things. And on that pandas series, we stored it under the name S. We can do the same vectorized operations like we could do in NumPy. In fact, we can actually use just NumPy functions. For example, the logarithm and divide it by the square root of S, just something random, and we get kind of some values out of that in the same. But the important thing is that the pandas series keeps its index and so on. It stays exactly the same because we have here vector element-wise operations. Okay, what if we want to access different elements of this pandas series? The index we can access with s.index, just an attribute of this series object, to just give us kind of like a list of the keys in this series. The type here is so-called pandas index. It's also a certain data structure, but in principle it behaves like a list. So now if we want to access particular elements, for example, let's say we want to access the value ISA2, we no longer access this with S0, S1. So that would be the way, the NumPy way to do it. Yeah, so it even warns me that pandas is going to change something about it. It's not really recommended to use it. It works, in fact. So 1365, it's actually the correct value, but it's not really recommended. The better way to access data now that we have concrete labels with a semantic meaning, is that we can call the so-called .log accessor and say the name of the key, the name of the index that we want to access. So, for example, s log isa2 would give us the value of the corresponding entry. We can still use it by raw position with the ilog, or as shown before, until the next version with regular square brackets, but that's really not recommended. What if we want to access multiple elements? Well, we can just pass into this log accessor, we can pass a list of multiple entries in the index. So for example, Neckar-Westheim and Emsland, that would just give us kind of a reduced pandas series here. Just on the side, if we want to check what type our series is, we can see it's pandas core series. And if we want to check if something is actually something, we can also say if s.index, for example, is our pandas index, and that would be something that could be checked. That whatever object you have on the left side as a first argument could be the argument kind of is of the type of the second argument. You can still use slicing in pandas series. It's something that is actually rarely used, but in principle, you could also just say, I want everything from Neckar-Westheim to Emsland in the respective kind of sorting of my series. And I can also do that by position, just like with kind of lists and so on, just with the ilog accessor, take the first two entries. If we really need to, well, we already saw one way to get the index of a series. We can also just get a kind of just get the values of a series. And that is, in fact, a NumPy array. So it's just kind of a one-dimensional array of the power plant values. And if I say what's the type of that, it's actually a NumPy ND array. Okay, so what's the difference then between the data frame and the pandas series? Pandas series is a single column. Once you have tables, it's basically a collection of series that share the same index. And then we are basically at a table in a spreadsheet. So the constructor looks pretty much the same, pandas data frame. One way to build it is from a dictionary of lists. So say we have different attributes. So capacity, type, start year, end year. These would correspond to columns in the data frame. So the lists here need to be of the same length. In this case, we're going to add 3 entries. We can use NP-NaN, which would represent none values. It's one way to do it. And then each entry, each position in these lists represents one power plant. And then when using the data frame constructor, we pass the dictionary. And then one thing that we also have to provide is kind of the index for each of these 3 entries. Neckar-Westheim, ISA2, and Emsland. And then what we get out of that is just kind of each power plant has its own row, and they share a set of different attributes. In some cases, it might be useful to transpose the data frame, and then it looks like that. Now the power plants are in the columns and the attributes are in the rows. That's also fine. So now that we have this data frame, we can just like with NumPy, we can use statistical functions or kind of general reduction operations. So for example, calculating the minimum of each column in the data frame. So that's the default. We'll calculate across each of the different columns. And interestingly, it works for both numbers as well as strings. So for numbers, we'll just look for the kind of minimum. That's, I think, clear. But then for the type, for example, we have strings, and there we'll just do kind of alphabetical sorting. For the mean, it looks a bit different. What is the mean of a string? It doesn't really work. So if let's say, I just try to call df mean, it will complain at some point. It will say type error. And again, error messages, you read from the bottom to the top, scroll all the way to the bottom, because they can be lengthy, but the most important information you find at the bottom. So say, could not convert PWR to numeric. It just means that it couldn't kind of, to calculate a mean, it needs to be something numeric, and this couldn't be done for the strings. So one thing that we can do if we have a bigger data set where we're not sure about all the different datas, you can also say calculate the mean for everything where you can. So calculate numeric only, and then we just get the numeric columns, capacity, start year, and the end year. And for any kind of column where there are only missing values, the minimum or the average will also just show up as a non-value. One thing that you maybe remember from last week's lecture, where we kind of had this one kind of table of time series of wind, solar, demand, and prices, was this kind of initial statistical view of the data frame. And that is created from the so-called describe function, a useful function for just inspecting as a first step the values or the value ranges, some statistical information of what data is actually contained in this data frame. So here you get this overview of the how many values are there, what's the average, what's the standard deviation, minimum, maximum values, as well as different quartiles. And you see here, for example, for the end year, you would see, okay, in this end year, there's actually 0 values because all of these values are none, and so on and so forth. This is, of course, we have a very simple, small data frame where it's maybe still easy to overlook. But now consider a data set where you have 10,000 or 100,000 entries and 50 different columns, then this can be quite useful. Okay, so accessing values in the data frame. So now we actually have to think about 2 dimensions. We have to think about accessing particular columns and accessing particular rows. And the syntax is different for each of them. So if we want a single column of a series, we can use our regular kind of square brackets without anything. For example, if we want the capacity column, we can access df capacity. In fact, as long as your column names do not contain any spaces or other special characters, you can also use this so-called attribute syntax just by, instead of using the square brackets, you just say dot capacity. And that will give you exactly the same thing. You could also say and here, kind of underscore also counts as non-special character. This can make your code sometimes a bit better readable. Okay, so if we want to access particular rows, we use what we know from series. It's exactly the same. You use this log operator, but for example, for the Emsland power plant, and the return statement is now a bit different. In the pandas series, there's only one there's only one dimension basically. So if we access something, we would get a scalar value out. But now with the pandas series, if we want to access a certain row, we actually get a pandas series out, a pandas series where the indices are the columns. Yeah, we get for Emsland, we get kind of the different columns, capacity, type, start here, end here, as indices. And also here, we can use, in principle, the ilog functionality to access things by position. Okay. So how does it now work if we want to access a particular value? For example, the start year of one specific power plant, or in the example at the beginning, the weight of one particular player. Well, here we also use the log accessor, and here we would provide two values, pretty much like how we would access NumPy entries. The first value would be for the rows, the second value for the columns. So rows first, columns second. The rows would be axis 0, the columns would be axis 1. And in this case, we would get 1988 out. And if we want to build subsets, we can pass for each of these two dimensions, we can pass lists to get the subsets. That would give us just a subset of the data frame. Okay, good. So we now know how to access columns, how to access rows, and how to access particular values. If you want to access a particular value, you can also use @. For example, it's just another alternative to log. So mathematical operations work just as well just like for pandas series. In fact, we're accessing here a pandas series, multiply it with 0.8, and if we want to assign this new set of values to a data frame as a new column, we can do this with the following syntax. We can say df square brackets, and inside we write just a new name for a new column where we want to store the data, and say should be 80% of the value of df capacity. And when we execute that, what we get out is kind of our original data frame plus an additional column with the reduced values, and the index is checked. It's still the same, so they share the index. So it's just another extension of the column. Okay, so so say we added this column by accident, or we're not happy with the name. How can we remove this column? Or say one of these power plants goes out of operation. How do we remove this row? Well, for dropping or removing columns, we can use the drop function, where we can just say what column to drop, and then we specify the axis along which we want to check for this column name. So it could be axis 1. So if you want, you can remember 0 is always the rows, 1 is always the columns. And that works. If you can't remember it, like I used to for a long time, you can also just write not all that. You can also just write columns or rows. It's a bit longer to write, but it's explicit if you don't remember what 0 and 1 stand for. And that would just remove, return a data frame that doesn't have this column anymore. But if afterwards we access df, it still has the column. So it's not an in-place operation, So that goes back to last week where we talked about pure and impure functions. Some functions, they modify the values of its input. In this case, it would be df, and some do not. And most pandas operational functions, they don't, they are pure functions, they don't change your original data frame object. If they just return a new one, basically. But in many cases, you can pass the so-called in-place keyword argument, where you just say, it's basically you want to assign your new processed output of that function. You want to assign that to the original input. This is an in-place operation because it changes the input of the df in this case without assigning it concretely. So this makes the function into an impure function. So now if we look at df, we don't have that column here anymore. An alternative to that would just have been to do this. We want to override the value of df with the output of df plus some function. Sometimes maybe it makes sense. So, I mean, this column end here, it doesn't add anything here. So maybe sometimes we want to remove columns that don't contain any values. And that we can use the drop nar function for. If you do it along axis 1, it would look for columns that have all none value. And you can even specify if you want to remove the column if all of its entries are none or if any of its entries are none. Sometimes you have a rough idea of some data is missing, but if it's missing, then it's usually kind of some concrete value, or you really need this data and you're happy to take a guess at what the value would be. And then you can use this fillNav function to fill in with fallback data, for example, filling in the year 2025 or something like that, or 2023, because you read in the news that the nuclear power plants went out of operation in the last nuclear power plants in Germany went out of operation in 2023. And then it would go through all the different columns and fill up this, this value. What can also happen, so again, this was not an in-place operation, so still we have none in the df, but let's say we want to assign a certain value to one of the power plants, so for example, Emsland end year 2023. So what we now have is that kind of our last entry here, Emsland, has an end year given, and we can also fill up, I mean, either we use this fill_nar function and give a default value for all of the missing values, or we can use functions like bfill or ffill, backfill and forward fill, which just says, okay, assuming these are sorted in some way, say they're sorted by end year, and some of them don't have it given explicitly, we maybe want to say, let's fill it backwards. Let's just take the last known value and then go up until we find the next valid value that is not none. That would then kind of fill that up back to the very beginning because there are no other values given. So just let's make another example. So let's actually fill in two values. So let's say 2023 and 2026. So our data frame looks like this. If we use backward fill, it would kind of take any none and look at the next valid value. So in this case, if we call d backfill, it would fill it up with 2023. And if we use the function ffill, it would just say, look for the first previous known value and fill up the value from that. So in this case, it will fill up with 2026. Yes, that's the question.
And fill function does it for the whole structure.
Mm-hmm.
If I want to this column, I just enter that in the bracket.
Let's see. I'm actually not super sure. No. But so in this case, what you would do, you can say you want a specific column, then you can apply that to the specific column and then override the value. So that would be a common operation to do it. And that would have exactly the same effect. But you're right, it's like this. You would rarely have a fill value for all the columns in the data frame because they are different. And this is actually more common that you would see. Yeah. Okay. So sometimes it can be useful to rename columns. So let's say we have some columns X and Y for the latitudes, and we don't have any values given for that. So just another two columns with none values. And maybe we're not happy with X and Y. We actually think it should be called latitude and longitude or lat and long. We can use the rename function and can say in what dimension do we actually want to rename? Do we want to rename columns or do we want to rename the index? And then we can provide a dictionary of kind of translations that X should go to latitude, Y should go to longitude. And then we actually just have kind of renamed the columns. And so that's one way to modify kind of everything around the labels in the columns and the index. And it can also be useful to sometimes replace values. So for example, PWR, maybe nobody knows what it stands for. Maybe it's better to write it explicitly that it stands for pressurized water reactor. Then we can use the replace function where we again pass a dictionary of things that should be translated from as the keys and to as the values. Again, remember that none of this is in place unless we explicitly say it is. Okay, so modifying values, we already did two examples of that, but we can do particular values with a lock. Since say ISO2 start here should be 1999, or the capacity of the Amsterdam power plant there should be 10 added to that. And these operations are in place. And now we have kind of ISA2 start here 1999, or if I do 2000, then it would be 2000. But the more often I execute this, you see here the capacity always with every execution, it rises by 10. Yeah, it doesn't know anymore what the original value was, but just kind of takes whatever is inside the data frame and adds 10 to that. And if I execute that repeatedly, the number is just going to rise. Okay, so and adding values, you can add values to multiple rows by passing a list of rows, and then you just need to make sure that kind of the length of this list you want to change the y coordinates for matches the length of the list that you provide here. So in this case, 3 entries and 3 entries. Now we have coordinates, at least y coordinates, for these power plants given. Okay. Suppose now that we have another data set of the other three nuclear power plants that were in operation recently. Grundremmingen, Gronde-Brookdorf, kind of 6 more. Call it DF2. And we want to combine the two data sets now. So this should be relatively straightforward because we want to extend it actually along the rows and the columns are all the same. So what can we do? We can use the concat function where we just provide a list of different data frames that we want to concatenate. Concatenate just means kind of put below each other. And then we have one data frame with 6 entries. Note that I shouldn't re-execute that because I didn't change the name or basically overrode the content of df, and df is also a function argument. So if I re-executed that now, I would end up with 9 entries, and 3 of them were duplicated. So now it gets, well, you could say now it gets a little bit more complicated. We can't see all the values at once anymore. Maybe it's time to sort the data in some way. And there's 2 things by which you could sort. I mean, one obvious thing is you maybe want to sort by index, like alphabetically, or you want to sort by one of the columns. You can sort by age or by the capacity. So if you want to sort by index, there's a function sort index. So far, so intuitive. So that will give us everything in alphabetical order. Or we can sort the values. But here for data frames, we have to specify by what column. And we can also specify whether it should be ascending or descending. So here we say ascending false, so it should be descending. So the largest values should go first. Here's the Amsterdam power plant, which we played with earlier with a high value, and then one with smaller value. But we could also just do it by end year and get a different picture here. Say we want to kind of filter out all the power plants that have a capacity of less than 1,300. We can basically do the same that we did for NumPy arrays. We can create a mask with this operator here, df capacity greater than 1,300. This will give us a pandas series with a list of the power plants and then a true-false value of whether the condition I asked for is true or false. And this I can basically just copy in here in a square bracket around the data frame, which would then give me just a subset of power plants where that is the case. I can combine multiple such conditions together. Then I just need to be a little bit more careful about the brackets. So there is this AND operator. If I want an OR condition, if kind of either one condition or the other condition is met, then I can write this kind of vertical line. And around each of the conditions, I should put some brackets. And if I want to negate a function or a statement, I can write the kind of a tilde for that. Yeah, so that's just some Boolean operations, but in this case, we want to get all the power plants with a large enough capacity and that are young enough, and that narrows it down to 2 entries. Who of you has done some SQL in there? Is that a question? You have done SQL? Okay, question first. Okay. It would just be one straight line. Yeah. Other questions? Okay, then my question, who of you did some SQL queries at some point? Okay. So that's also something that you can do. Maybe makes kind of more complicated queries a bit more compact. It's not one-on-one SQL, but there's a query function that lets you write like text, like a column should be equal to 1988, and that would filter out all the power plants that have that start date. And if you want to use a variable there, like 1300, you can reference it with an add threshold. That is also possible. Okay. But that's maybe, I mean, that's just a side note. If you have some SQL experience, then that's maybe a more friendly entry point to filtering. Okay, so you saw already, Earl, yes, question. Yes. Yes, so there's a merge function that does exactly that. Or there's also a join function, depends a bit. I didn't prepare anything, it'd be a bit difficult to do it now, but so there's this concat is one way of combining data sets, and then there's join, and I think joining is based on certain condition, and then merging, I think it's through shared indices. I'm not exactly sure, but yeah, so there's ways to merge different data sets together. Let's see if there's good. Yeah, I think it's too complicated to go through it now, but yes, there are options to join different data sets. Can post it. Yeah, I can post it later if you want. So one example I made earlier is kind of you have a series and you apply some random functions element-wise to it. Think of this as like logarithm of divided by the square root of the series. But sometimes we maybe do not only want to use these basic functions, but something that is a little bit more complicated. And last week, I also introduced you to functions, functions that take some input, process it, and we've already used functions quite a bit, given it different arguments. Think, for example, of query or anything basically that appears yellow here in my console is a function that just takes some arguments, including df, and process it into something else. So if we want to apply functions to all values of a particular column or a particular row, we can do this with the apply function or the map function. So, I mean, let's just start earlier. So say we have df. I mean, if we want to normalize it relative to the largest power plant capacity, we could just say df capacity divided by df capacity max. And that's a relatively easy operation. You would then have kind of largest power plant would have a value of 1 and all the other ones between 0 and 1. But think now that we have actually something more complicated. We have to have some intermediate calculations based on some other inputs and so on and so forth. Then it gets difficult to do it. And we have to maybe repeat that at some other position in the code. Then it gets difficult to do it in this format. But an alternative to do exactly the same thing that offers more leeway to add complicated functionality is to wrap this in some in a function that we can reference later. So let's say take a normalized function. It takes some entry s, some value s, and we want to return s divided by kind of this capacity maximum. And then we want to apply this function, this function to all the values in this series. that's what the apply function does. It takes, so this entry here, the S, it's not a series. It's supposed to be a float. It refers to kind of one, well, no, well, one element in this capacity here, to which we always apply this function that we divide by the maximum of the column. And then we get the same result. And you might think now, well, this is completely useless. This was way easier. But here we can just write we could write just lots of complicated code here to process this and apply that multiple times to, for example, different columns. Yeah, so that's the apply function. This is what exactly this does here. And this is the easy version. There's apply, there's map, yeah, and I think the other options are deprecated now. They're not going to be there for long. So if you want to apply a function to all values in a column or a row, in this case, you would just kind of provide a different axis, a different orientation across which to apply the function, then the apply function is your friend. Okay, so now plotting. Pandas has basically built-in matplotlib plotting, just kind of a friendly interface to get to plots quickly. So take our data frame. We can say we want to plot. We can say what kind of plot we want to do, what column should be on the x-axis, what column should be on the y-axis, and we can plot the start here against the capacity. And we can also do something like access the series. The series also have a plot function where we can say we want to plot, and then we can say what type of plot, bar h, and then we can pass all the regular keyword arguments of that we know from matplotlib. So in this case, would give us just the horizontal bar chart of the capacities of the different power plants. And here we could just use, we could just import matplotlib as pyplot. This is not good style to import it at that point, but it works. But we could say the X label should be capacity in megawatts, and that shows up then here. So that's maybe not much more difficult than doing it through matplotlib itself. But one nice thing in pandas is that it works very well with time indices. So there's a particular data structure in pandas that is made for indices that represent some point in time. So before we talked about this pandas index class, and there's also a pandas datetime index class, which kind of just offers more functionality to kind of resample the data, for example, upsample it, and work with it. And we can create it, for example, with this pandas date range function, where we just say what the start date should be, what the end date should be, and what the frequency should be. So here we want daily time series. So kind of each time step, each row would represent a day, starting with the 1st of January 2021 and ending with the 31st of December 2022. So again, kind of the end is kind of closed interval. The 1st of January 2023 is not included. And then we can kind of use some information. For example, the kind of counted day of the year is an attribute of this index, and we can use it to process it in some functions. So let's maybe go through that step by step. So the time would be now not just an index, but a date time index, but otherwise looks pretty much like a like a regular index, only that the data type here, D type, is kind of date type object. And we can get the day of year, would just count from 1 to 365. Actually, I said something wrong. The 1st of January 2023 is in fact included. In total, we have 2 years plus 1 day, 231 days. And this is just an integer, so that means we can just use it in any function. For example, this values function, which gives us just, some 731 random values. And that we have kind of one list of values of the same length as our time index. We can make a pandas series out of it that then looks like that, where we have a timestamp index and some values. And this is now nice if I just say we want to plot this, because, well, so far everything looks exactly the same, right? But the nice thing is that my x-axis is now formatted nicely. It recognized, oh, this is a datetime index. I can actually put kind of more informative axis labels on the x-axis that has the datetime index. And also, by having the datetime index, we can do slicing. For example, if we want all the values of May 2021, we can quickly kind of get a subset of this period. Or use the slicing notation if we want the first, first half year, then we get kind of one arc of the sine function. And we used already day of year, but you can get, for example, the month or the day. So day here would count the day of the month. And I think there's even something like weekday. So it would say the 0 is a Monday, 1 is a Tuesday, and so on and so forth. And could be, for example, useful if you think back to the lecture, the time series that we looked at, that the weekends had some other kind of electricity consumption pattern than weekdays. And that means that, and having this information can be useful kind of to verify kind of what the average, we could use this information here, this part of the index, to find out kind of what does the average profile on a weekday look like compared to weekend day. There's more information stored. I mean, information about the month is stored. So we can also use it to resample the data. We can resample, for example, by month. It's identified by the ME keyword here, and take the average. And let's just do that. It's a bit like a group by operation. We just take kind of now for each month that is represented by a time index for the last day of the respective month. We get the average. We can also do it by week or by day. By day, obviously, doesn't make a lot of sense because we have already a daily resolution, and I don't think so. This, for example, wouldn't work because, oh, well, it works because we can upsample the data. Let's just say we want to upsample to every 12 data. So we only have daily data, but we want to double the resolution. This would be, and now we have also slightly longer daytime index because we need kind of the time of day as well as part of the information. But here would be, for example, a case, well, as a first step, we can use ffill, forward fill, and take over the other value. Or I think there's even an interpolate function, which just, I think by default maybe does a linear interpolation between the values. Yeah, and that we can plot, and then we can have a maybe coarser resolution throughout the year, and that sometimes can help identifying trends. For sine and cosine, it doesn't help, obviously. Okay, good. What else is there? I mean, so far we constructed the data frames ourselves, which is of course quite impractical and defeats the purpose of having this data structure. Well, because we're not going to write a dictionary into code with 1,000 or 10,000 or 100,000 lines. But that means that we have to find a way to read data into pandas, as well as writing kind of processed files into a file so that we can access this information at a later point or export it to some other tool. And there's readers for many different data types. So there's a reader for Excel files, but there's also a reader for CSV files, so comma separate values, just some text file. Let's see if I have one here. No. But in principle, these files would look like this. We have value 1, value 2, and this could represent like the header. And then we have 1, 2, 4, 3, and maybe we even have an index of 0 and 1, for example. And this is kind of a very easy format easy format to store tabular data. So I brought one CSV file here with me. So maybe I'll just open that quickly. So this is, let's zoom into it. So this is a large data set because it has multiple 10,000s of entries, or multiple thousands of entries. But here you can see exactly that. You have kind of a row. The first row would give you kind of the names of the different columns, like the efficiency, capacity, country, and fuel type of the different power plants. And then the rest gets messy. But in principle, also the kind of rows. So here, actually, oh, interesting. So actually, the first one is kind of Emsland. It's a nuclear power plant in Germany with that capacity, that efficiency, and all these values are also comma separated. Just one way how data is stored. And in fact, so this can be, the file name can be some local file path, but in fact, it can also just be a link to a raw file stored online, like it is in this case. That's why we just paste a URL here. And we would just call the pd read CSV function on the file name. And what it will do, it will automatically recognize the different columns, and it will invent a new index counting from 0. But maybe we already have this ID column here in the data set, so we might as well just use that as an index. And we can say the index column that we want to use is actually whatever value we have in the first column in the data set. So that's why we put a 0 here. And that would give us kind of remove this new created index, but would actually use the ID that was provided. And then if we want to actually store that, we can store that under the name df. Yes. Mm-hmm. Yes. So let's just say, um, let's just do it, basically. So I go to where the source of this data is. I see here there's a power plants CSV. There's a download button, and it ends up somewhere in my download folder. It's not the first time I downloaded it, so it has power plants 4 CSV. The way I would load it would be, instead of this URL, I would write I would refer to it kind of my downloads folder, power plants CSV. I think in this case it was power plants 4, and I would load it, and that would load it from kind of local file. But it has to be, it can be, this was an absolute path, but if, for example, this file was in the same directory as as my current file is in, then I could also just provide uh, a relative path. So in this case, it could also just be power plant CSV. And in this case, it will not work because it will say, oh, I couldn't find the file or directory power plants for CSV. Okay. So what we can call, if we have an unknown data set, is of course we can call the describe method. We would get kind of information about that there are at least 30,000 or almost 30,000 entries at different power plants in this list with the kind of median capacity of 8.2 megawatts, and the biggest one is 6 gigawatts, and so on and so forth. I can also call I can also call df.info, which is kind of similar like describe, but gives me more information about what the data types of the different columns are and how many non-null, so not, yeah, how many entries there are. Would say, for example, country, set, technology, fuel type are all strings. So these strings would show up as object here. And then I can also see what columns have a numeric value. So two methods to give me kind of um, broad overview of the data set. Just another example, the date in is a substantially lower number compared to the number of power plants with the capacity. So that just means that kind of at least this difference has a missing starting year. So we don't know when this power plant went in, or when these say 7,000 power plants went into operation. Okay, so this data set, if we want to store something, for example, we can call the function toCSV, would just mean, yeah, we store something into a local file, for example, tmp CSV, and this would then actually show up here in the same directory. And that could be then also be reloaded again in some other script, for example. Okay, I hope you're not too tired yet, because there's one more kind of conceptual jump that we need to make. And that is about grouping and aggregating. So say, I mean, we have this list of power plants, right? Just to illustrate the point, let's pull it up. So we have this list of power plants, and this quite fine-grained information. But say we want to know something like, what is the total capacity by country? And in principle, we have all this information. We just need to kind of look into each of the countries and sum up all the capacities that are in the country. And we can even do it for a particular fuel type. We can just, we went through the filtering operation. We can filter iteratively about all the nuclear power plants in Germany, the hardcore power plants in Netherlands, the hardcore power plants in Germany, and so on. Go through all the different steps, and then sum these up. we could find a way to calculate that, but it would be maybe a bit tedious. And obviously, there's a built-in function to simplify such processes where we want some aggregate information where some of these columns become the new indices. For example, if we want to know the total capacity by country, we would have a country as the new index and capacity as the new values. And we want to have that as a series. And the way that is done is this group by operation. We can say we take our data frame, call the group by function, and we say which column we want to group by. So that is going to become our new index. We want to group by the country, and for each country, we want to take the capacity and calculate the sum of that. And if I calculate that and execute that, I would get, as expected, kind of for each country, I would get a series, first of all, where the country becomes the index and the sum capacity is the value, and so on and so forth. And we could even sort it from kind of, we could get the top 10, for example, the capacities, the countries with the largest total capacities. And what happens here is maybe something that is visualized with this illustration. So we started to say we have these two columns. Call 1 would be the country in our example, and call 2 would be the capacity in our example. And we start with a data frame where all of this information is kind of included at once. And what the group by operation would do first, it would split up the data frame by groups of the different countries, by the kind of column that we provide, by the different values, by the unique different values that we have in the country column. So A, B, and C. And for each of them, we would do some transformation operation. We would apply some function to it. For example, summing it up. We could have also just calculated the mean, also possible, or the min or the maximum. Anything is possible. You can even combine it with more complicated functions to this apply method. But let's stick with the summing up the total capacity. Then we get kind of a reduced set. And I don't like this illustration here, but basically here we're done. We're just concatenating these three different values, three different reduced sets where we have kind of a total value for country A, a total value for country B, a total value for country C. And what we end up is kind of the equivalent of this one here, only that we have more countries here. Okay, so that's the concept of group by. Take a data set, take one column, split it up, and for each of the groups, do some calculation and concatenate the reduced results back together. Now the twist is that you can actually group by more than one column. So take one example. We're interested actually in the total capacity of each country and fuel type. We want to know kind of total capacity, total nuclear capacity in France, total coal capacity in the UK, and so on and so forth. So actually we have two columns to group by, and that also works. So here we could also just pass a list of two different columns and do the same, and then take the capacity and sum that up. And what we get out of that is something that looks like that. So maybe that takes a moment to explain. So now we have a so-called multi-index. Multi-index because we have two columns in the index, slightly more complicated structure. But why multi-index? Because we have two elements that describe the value. So Albania, hydro, Austria, hard coal, United Kingdom, solar, biomass, waste, and wind, for example. But now we have this information split up more granularly. And what we can do with a multi-index, especially if it's just kind of two, which is just another bit like the datetime index, is a special form of an index. We can use so-called unstack method to kind of reshape the multi-index pandas series into the data frame. So we just kind of how to imagine that is maybe you take out the second index and pivot that to become a column. So yeah, so just calling capacities unstack, it will give us now a pandas data frame where kind of one of the index levels is retained as an index and the other index level is moved into the column dimension. And there's now a lot of non-values because I don't know, some countries may not have a geothermal power plants. Actually, in Europe at least, I think the only that has substantial amounts of geothermal is Italy. Power plants, geothermal power plants. And yeah, so not all of these combinations are filled. So here it would actually be one of the cases where you would say fill now with a 0, because we know that any values where we don't have any information from the granular data that we have, it should be 0. And we can also just transpose that as well. We could move the columns to the index and the other way around. But now with the zeros, we could also do lots of nice things to show the data in a better way. We can round it to the first decimal place and so on. But still, it's kind of 13 rows, 36 columns. So it's not enough to see these dots here. It's not enough to show everything here in the console. So maybe let's just export it to CSV. And I'll just kind of go to this folder. Where is this file? So it's here at the bottom. You can also just open it somewhere else in Excel, for example, and look at the data there. Well, I don't have Excel, I have LibreOffice here, but that I can kind of import that and process that kind of outside the Python environment and work with that, or just look at the values, or yeah, do other filter operations here. But that is not, of course, not what I'm teaching. So let's go back to Python. But we're actually done in terms of new content for today. Just a few takeaway messages in pandas. Be careful what you expect to be in-place operations and what not. Most, unless specifically asked to do, are not in-place operations. They maybe show up in the output of a cell, but they are not persistent. Pandas, we can use it just for reading from files, inspecting them, cleaning the data, performing some analyses. But most often we're kind of reducing data, processing data into some form of aggregate, some form of process data, to put them later into energy system models. There's a question. Yes. Yes. So take just one of our data frames. I think I've used the head function before. It gives you the first 5 values. And the tail is exactly the same. It will just give you the 5 last values. Yeah. Yes, so you can just put a number here and then will be default is 5, yeah. So one other useful thing, just thinking about it, if you want to find the 5 power plants with the largest capacity, for example, you could also just say 10 and capacity. So just the column and how many, and that will give you kind of the nuclear power plant in Zaporizhia, for example, in the Ukraine, which is kind of 6 blocks of roughly 1 gigawatt. That's kind of the largest complex of a power plant around. Yeah, so, and of course, then there's also, I think it's n smallest. And these will be kind of local run-of-river power plants in Scotland, or data mistakes, because capacity 0 maybe doesn't make too much sense. Okay, so I would say it's time for a break / closing the kind of more formal, more central part of this session today. There's for each of these two notebooks, there's exercises that you can go through, that you can try out yourself, kind of apply the things yourself that we learned about today, just as well for pandas. Feel free to stick around or do it at home. I will stay here for another hour or so. And if you really need to look at the solutions, you can find them here on the course website for NumPy, Matplotlib, and pandas. You can also just inspect individual elements, but I would just close it for today, for the central part, stop the recording, and then roam around and help you with individual things.